Alrighty, folks. Well, what's good for the goose is good for the gander. I'm going to analyze my own log. What's happened is I rebuilt my copter with little b ESCs from Multi-Rotor Mania. Uh, I had some F12As, which were okay. They weren't terrible, but they certainly weren't great. And when I went from BL Heli 13 to BL Heli 14, I started to get a sense of what kind of a performance difference ESCs could make. It was way bigger than I ever realized. But those ESCs couldn't run BL Heli 14 without having a lot of vibration. I won't go into that. So I got some little Bs, and I would suggest anybody out there who wants to up the performance of their copter to look to get a quality set of ESCs. If anything, I think they probably have a bigger effect than motors because the motors ultimately, they may have vibration, right? A higher end motor may have less vibration, perhaps, but ultimately the motors turn power into thrust. And the ESC is really what tells the motor what to do, and I think it probably has a really big effect. Um, so I've upgraded the little b ESCs, and I also have switched to an X4R receiver. So I'm running S-Bus serial instead of CPPM. CPPM, because it's an analog uh, protocol, it doesn't have inherent sort of digital error checking like checksums. So what CleanFlight does is it reads several CPPM pulses. I think it's four by default, and it averages them or checks. It checks for anomalous pulses just to make sure that there's not some random glitch that's going to cause a problem. And what that means is that there's something like 80 milliseconds of latency built into CPPM just so it can do its error checking. Whereas with SBus, there's no need for that. As a digital protocol, it has, I guess, checksums probably that just immediately allow it to detect invalid bits. So those are the two changes I've made. I have not changed my PIDs at all, and it flies really good. But I'm really surprised that going from from a sort of a Atmel ESCs with very mediocre braking and BL Heli 13, which is less aggressive in its commutation of the motors. It doesn't push the motors as hard. To BL Heli 14 with a much higher end ESC capable of much better braking. I'd be very surprised if in fact the old PID values were correct, as it were. So I gave myself a taste of my own medicine, and let's do a little analysis of my flight. Here's my zoomed out gyro traces. This is with gyro LPF 188, gyro cut of 100, P-term cut of 50, and D-term cut of 17. So I just tried to set those back to some nominal values, maybe a little bit high, in hopes that I'd be able to, these better ESCs would be better able to deal with the filtering. I don't know. And it does look pretty good. I had very good flight performance. I'm going to post the raw video and you can watch it yourself if you like. But the flight performance, there were no oscillations, vibrations, twitches, or anything weird. So maybe this speaks to the fact that better ESCs are also able to have much better filtering, much less filtering applied to them. Or maybe it speaks to the fact that it had something to do with the S-bus latency. I mean, I really don't know which of those things it is. But my gyro traces look pretty good, even for the low amount of filtering I had. And I'm really surprised to hear that because I don't think they look this good. I'm not going to open up an old trace to see, but maybe if you feel like it, you could dig back and find an old video of mine that I posted. Maybe we'll get lucky and I would have shown the screen. I don't know. But I don't think they look this good. And it's the exact same motors, exact same. Everything is the same except for the receiver and the ESCs. So this is fine. My filtering looks fine. Maybe could even decrease the filtering. Maybe even try gyro LPF or gyro cut of 0 and just use P term and D term and see how that works. So this is very interesting. Let's have a look at this. There's a roll. Not much to say about the roll, frankly, but it is interesting. Have a look right here. This has got to be, it has to be D-term spike. By the way, this is an older firmware. It's from back in June. It does not have RC smoothing applied. So it's the reason I keep going back to this one is, well, the bottom line is whenever I try to go to a 1.10 based firmware, something isn't right. And I'm not going to go into all the details of what it is. It's always little things. And I always end up just saying, ah, screw it, I'll go back to what works. So this is an older firmware. It does have the soft filters, but it does not have RC smoothing. So certainly this is going to be, let's put RC command in there. Yeah. So certainly we've got these steps here, and even with an S-bus receiver, we're still going to have these steps. They're just going to be much smaller than with a PPM receiver. So here's our D-term spikes that our RC smoothing is meant to fix. And there you go. That's just, there's no way around that. And then if you look here, oh my gosh, I'm so happy with this roll. Look how close to the axis my P-term is during the roll. This is fantastic. I got a picture perfect roll, and I'm so pleased. I couldn't be more pleased. Push into the roll. Very little push out. Just a strong push in. Oh, no, sorry, I got it wrong. Strong push in, little push out, and then boop, right close to the axis until the end. I could not be more pleased. Now I have got some prop wash oscillation, as you might expect. There was some right there. You might have could have heard it, and you certainly can see it. And I'm not sure how much I'm going to try to tune that out. I think I could reduce, maybe I'll try gyro cut of 0 and see how that flies. The reduction in latency should help a little bit, and but I'm not sure I want to reduce my P gains much to get rid of that, because ultimately I feel like it's flying pretty snappy. In fact, well, honestly, it almost feels like it could be more snappy, but I probably will address that by going up to 4S, at which point I'll probably have more snappiness than I know what to do with. So I doubt I'm going to increase P. And it doesn't even really make sense that a more aggressive ESC could result in increased P. Maybe the better braking means I can increase P because it is more able to, it's more responsive, and so it's able to handle the potential oscillations better. Don't know. And how about a flip? Let's see how a flip goes. Let's watch that again slower, and specifically, let's look for the bounce back. Was that? I might have been at faster than 100%. I apologize if I was. Let's watch that at 50%. Boy, got a little bounce at the end there, but that is so much better than it used to be. And also, I can't help but notice how sort of aggressively oscillating oh, this is the roll axis. I apologize. Guys, I'm so sorry. I'm so excited about these new ESCs. I just don't even know what I'm doing. There we go. So we've got the D term kick due to the jumps in RC command going into the roll. That's normal. There's just spikes, and those stair steps in RC command result in these spikes, and that's without RC smoothing. There's nothing you can do about that. Push in, push out. A little bit of oscillation here at the end. And there was a little bit of a bounce, but boy, it wasn't much. It wasn't much. It sure looked like it stopped pretty sharp. So I don't know. I may want to reduce eye gain. I had my eye gain set really high on my old setup because I had problems with changing pitch due to throttle changes. And I wonder if I can reduce that back down with these, maybe these new ESCs somehow are going to fix that. This jump in eye here, I'm not sure that eye should be that responsive under most normal conditions. And then I decided to do some of these punch outs that I recommend for you folks. Let's have a look. So when I go to high throttle like that, I'm going to look for oscillations. I do not see oscillations in the P term here. And really roll is usually where it's going to show up the most. And I do not see oscillations here. So this frankly may be a little softer than it needs to be, and could use either less TPA or more P gain. There's a little roll. Again, almost picture perfect here with the P term very close to the axis in the middle of the roll. And here's a float at the top. And it's pretty good, although I did bump the stick a little, which I shouldn't do if I really want to be scientific. Let's watch it again. Okay, I found one where I don't bump the stick at the top. Let's try this. So here, it really just did not change attitude at all when I throttled up. Here we go, watch it again. Nope, it's this one, isn't it? I believe it is. So right there, I would look for a pitch, usually a pitch forward, but maybe a pitch backward, and I don't see it. And right there, I would look for a pitch, usually it would be a pitch up, pitch backward a little bit at the top. And again, I don't see it. As I go to zero throttle, or darn near zero throttle, I will end up with a little bit of wobble, just because there's very little authority. See, it started to fall a little bit there, and I throttled back up. So I might have to investigate that, because it should be really solid at zero throttle. I'm not sure about that, but I've got another video up where you can see some zero throttle descents, and it just is rock solid because I have the idle up switch. So I'll look into that, but it's pretty good. And here's one more that I'll show you. So yeah, pretty solid. The I terms look pretty solid there. Maybe let's explore lowering pitch I a little bit. And then I think maybe I'm going to try a little bit less filtering, try gyro cut of 0 and see how that flies. And then potentially I'll even try increasing P gain a little, which is completely counterintuitive to me, but you know, the black box traces and the copter's behavior don't lie, so we'll give it a go. All right, hope that was helpful. Happy flying.